Well, thank you very much. It's a pleasure to be here. The talk that I'm about to give, I gave for the first time at EUI Florence about a week ago, and the time I had there was an hour and a half, and it was perfect, coincidence with my slides. But this is 45 minutes, so I'm really going to cut a lot of stuff out and move along rather rapidly. The beginning part of the talk was really trying to give my point of view that we have to worry a lot about the extreme tails of this distribution, that there's a lot of uncertainty in projecting temperatures and climate from carbon dioxide accumulations. That's the famous Keeling curve. This is 800,000 years of data on good quality data in this compared to other paleoclimate data on carbon dioxide levels. They never go above 280, or almost never. We're now at 400 of carbon dioxide, which is about up there on the graph, and 450 of carbon dioxide equivalent. So you can see we're way outside of the historical range. If we keep going, this rapid increase in carbon dioxide will be unprecedented on a scale of many tens of millions of years at least. So, okay, here I'm trying to fit a probability distribution to so-called climate sensitivity and coming up with some conclusions. You can see here that the probability that T is greater than 6 degrees centigrade goes up quite rapidly with the carbon dioxide concentrates. It's even now at 450 parts per million of carbon dioxide equivalent, there's a 0.3% that the system will react by eventually going up by 6 degrees centigrade. And that increases rapidly, so that it's something like 700. The median is 3.4 degrees. Maybe this is livable with, I don't know, it's sort of borderline disastrous, but the probability of being greater than 6 degrees, 11%, which is disastrous. Okay. Okay, here we go. I want to just highlight, and I want to re-examine the question of whether tradable permits are superior in international negotiations, or whether having a uniform price is superior in international negotiations. Now, there are classical arguments in favor of carbon taxes over tradable permits and classical arguments against. I'm arguing, this isn't on the slide, I'm arguing that classically in favor of price, a literature going back many decades, 30 years or so, in favor of price over tradable permits would be that, I'm going to give 3 reasons, you could give many more, and many more opposing. Price stability is delivered by carbon taxes, and I think that's an important point. Different people will put a different weight on these various aspects, but the fact that under a universal price there is stability which people, consumers and producers know about beforehand, I think it's quite important, because if the price destabilizes, the population doesn't like that, and the politicians don't like that, and there's a danger of discrediting all economic approaches. A second classical argument might be that there's no cross-border payments with internationally harmonized price. The countries, I'll emphasize again and again, that in this scheme of internationally harmonized prices, there's a single price, but each country, that acts like a tax, but each country is taxing itself by the price of carbon and gets to keep the receipts, the revenue receipts, which they can recycle or they can alleviate, lower other more distortionary taxes. And finally, I think, along with many others, that it's easier to administer an international price on carbon. It's less prone to corruption and stealing by kleptocrats than cap and trade is more prone to corruption than than a tax, which is more transparent. Now, you could argue again, on these three things, you could try to argue the other way. It depends on sort of what your weights are. If you could try to argue that price stability is not important, or that cap and trade comes close enough to price stability. You could argue that in terms of cross-border flows, they're going to have to occur in terms of a green fund to induce other countries to join in. So there's really not much difference. On the administration, you could try to claim that cap and trade is no more difficult to administer than a price on carbon or a tax on carbon. I come out on these classical grounds in favor of price. Now I'm going to add some new arguments in favor of negotiating a uniform minimum carbon price, internationally harmonized but nationally retained. This is a new, I don't think it's so profound, but it's a new approach. It hasn't been out there before. And some of the arguments I understand perfectly well are behavioral, they're not rigorous, they're subjective, they're legitimately criticizable, they inherently involve making judgments, but the problem is important and it wants new thinking. So let's go back to basics here. Let's disregard, to some extent, this classical literature. What are three desirable properties that we would want for a negotiating instrument? Okay, one is to induce cost effectiveness. That's near and dear to the heart of an economist, that we want that the marginal costs among all producers of carbon dioxide, the marginal abatement costs are the same. Now, these other two are emphasizing features that hasn't so much been emphasized in the literature. It would be desirable if the instrument were of one dimension, centered on some kind of low dimensionality, hopefully one dimension, centered on a natural focal point to facilitate finding an agreement with relatively low transactions costs. So here I'm invoking the spirit of Thomas Schelling, who talked a lot about natural focal points. It's been, what is a natural focal point? It's what everyone thinks is a natural focal point. So there's no question this is a bit circular, but Schelling made a tremendous contribution with this, I think, in a kind of an informal way, saying that this is an important issue to get things down to some natural focal point and then to negotiate on the basis of that. That's my interpretation of negotiation. And the relatively low transactions costs, that's in the spirit of Coase. It's a loose interpretation that the lower the dimensionality, the easier it is to get an agreement. If you have to negotiate with every single person on planet Earth, you won't get an agreement. And now the third thing, which I think is actually the most important, although this was not emphasized at all in the literature, the instrument, which is hopefully of one dimension, thereby, and it induces cost effectiveness, should embody what I'm calling a countervailing force against the narrow self-interest and against free riding by automatically incentivizing all negotiating parties to internalize the externality. So we would like an instrument such that when the world votes on it or seeks agreement on it, parties are not necessarily going for what is in their own narrow self-interest. Somehow the instrument itself is tied up to a general agreement that will lower or raise emissions. This sounds very abstract. I'm going to get very concrete in a minute, but this point of countervailing force, I think, is important. We don't have that now with pledge and review. We don't have that now. I don't think we would have this even with cap and trade. So using these three criteria, I want to compare and contrast idealized binding harmonized price with idealized binding cap and trade system. Now, an important point, what do I mean by price here? Really, countries could be doing anything they want. The uniform price is operating, which might be the price on tradable permits within a country. That price is operating like a tax, as if it's a tax whose revenues are domestically retained and internally redistributed. So it doesn't put this is something that the public does not understand, and we economists are not doing a great job of it, that when you have an internal tax on carbon dioxide, which is retained, people think of taxes as somehow they're going into some cloud in the sky and then they rain out over the Atlantic Ocean or something like that, something that's taken away from a country. This kind of tax is not taken away from the country, it's taken away from the emitters of carbon and redistributed throughout the country. All right, I'll have to go even more quickly. At a first pass, I'm going to return to this set of issues. Let's contrast negotiating one price throughout the world with negotiating n quantity caps where there are n countries in the world. Okay, the tradable permits satisfy condition one, and so does the internationally harmonized price or tax. Here on two, the price is one-dimensional. So when we're negotiating on the price to be universally charged, we do have a natural one-dimensional focal point. But this is absent, I would claim, in a cap-and-trade system. So you have a system in cap and trade where parties have to negotiate with each other because there is no international government to impose standards. And finally, there is no externality internalization for cap and trade. Everyone wants a bigger cap as possible for themselves, and they want a free ride on others. With a price, negotiating one uniform price, there is countervailing force because for myself alone, I want the price to be low, so it's not going to cost me more to emit carbon. I want the price to be low, but I don't want the price to be, at the same time, I do not want it to be too low, or I do not want it to be low. I want it to be high in order to induce other countries and other actors to lower their emissions, all right? So the price has this quality, and I'm going to quantify it in a minute. There is a critical distinction here which evaded me for a long time. It's very simple, I think. If you have an intranational, within a country, assignment of NCAPs, that is different from an international negotiation of NCAPs. So the U.S. sulfur dioxide program, which set up tradable permits in sulfur dioxide, the U.S. sulfur dioxide program, which set up a cap and trade system for sulfur dioxide, which is widely held to have been successful. In that system, the government assigned these caps on, these initial caps on carbon dioxide emissions. Now, maybe there was politics involved. Maybe there was some payoffs involved indirectly. But at the end of the day, the Environmental Protection Agency imposed these caps on power plant producers. This is very different. This is where you're negotiating. There's no government assigning caps to China and the US and so forth, but you're negotiating between these various countries. That's a very different situation. If you try to apply that, imagine this, that the US sulfur dioxide, to see, I think the depths to which it's wrong to bet on cap and trade as being effective in international context. Suppose in the national context of the US, that instead of the Environmental Protection Agency, along with consultations, instead of them assigning an initial number of caps to each power plant producer, or maybe to each state, that each power plant producer, that the government said to them, look, you figure out for between yourselves what cap you want to put on yourselves. Okay, you figure it out. Right? Well, it's ridiculous in that context. Nobody would cooperate. The U.S. government had to, it's a simple point, had to assign these caps. In the international context, there is no one to assign these caps. So negotiating end caps is very different from having a government assign end caps. Okay, let me go over to some technicalities. It's going to be fast. I'm hoping I can convey the essence of what's going on here. Now, suppose there are end countries. I have a choice of either working with the country as a unit or working with the individual citizen as a unit, and it doesn't matter. I can translate, economists among us should be able to see how you can translate from the one to the other. There's an isomorphism. For each cost of a country, there's a cost of the representative individual within the country. So I'm assuming that there are end countries and the nation acts on behalf of its assumed identical citizens. You can break away from some of these assumptions, but just to be clear, the U.S. has one type of person, China has one type of a different person. Again, I can generalize some of this. Okay, and I'm going to work in abatement. Again, it's just that there's more clumsy notation with working on the level of the nation, and also, not only is there more clumsy notation, but now you have to have a tax rather than a price. There's a price on abatement, a positive price. There's a tax on emissions. It's just messier to do it that way, I have learned by fooling around. Okay, so XI is abatement of individual I with cost CI of XI. The universal price of emissions is P. Then what is I going to do? I will abate to the level XI where the marginal cost of abatement is equal to this universal price. Okay? You do this in a cap and trade system, only the P would be uncertain because you have distributed quantities and you don't know what, you're distributed in overall quantity and you do not know what the price is going to be until afterwards. So the world total abatement would just be the sum of these over all people in the world. The benefit to I of having abatement level X in carbon dioxide is BI of X. That's the benefit in this one period of maybe 10 years or however long this instrument is intended to last, 20 years, whatever. The benefit to I is BI of X. The public goods optimality condition is that the optimal price, which is going to satisfy this for all I, must also satisfy the public goods optimality condition, the Samuelson-Lindahl condition, that the price should be the sum of marginal benefits. Now, it's not entirely clear, one has to be fair in saying, why this is the appropriate norm that an optimal price should satisfy. Because if you don't really have the logic behind the Lindahl-Samuelson condition, Samuelson-Lindahl condition, is that you're able to make transfers, and if you do not have this condition holding, there will be a way of transferring funds among these different individuals to make everybody better off. Okay, well, it's a well-known point of departure. I'm just saying that this is not as if this thing is so patently obvious in an international context. Okay, now, next. We've seen what I'll just call it the optimal price. It's a bit of a stretch, but it's a norm that's out there. But now I'm going to ask, what price would I most prefer, or I as one of these individuals? Well, the emissions price, PI, that I would most prefer solves this maximization problem. There's Yeah, there's a BI of the X of P, that's the total abatement in the world as a function of price, minus CI, the cost to I, of this abatement level for I, right? This is what I would most prefer itself for a price. Okay, so you take derivatives, and the first order condition is this. This is actually quite simple after you fiddle around enough. Let's use this condition 1, which is that the price equals the marginal cost, to say that Pi, which is Ci prime of Xi of Pi, equals lambda I Bi prime of X of Pi, where lambda I, which is defined this way, is the change in total world abatement per unit change of abatement for individual I. I'm calling that the externality internalizing multiplier for agent I. This is the countervailing force. So let's try to understand this equation a little better. Suppose lambda I were equal to 1. Suppose lambda I were equal to 1. Then we would have this condition that Ci prime equals Bi prime. That's exactly the condition for that a purely selfish, self-interested agent I would want. And they would want that their marginal cost is equal to the marginal benefit to them of the whole world changing. When lambda I equals 1, it's embodying the purely selfish Nash equilibrium free riding property. Now, suppose that, I'm waving my hands a bit, suppose everyone has an identical lambda, and there's symmetry somehow. So lambda equals, then lambda, which equals dx dxi, would equal m. So I'm moving my, per unit of abatement, the world abates by m times my unit of abatement. In that case, lambda I equals m, and then Pi is equal to m times Bi prime of Xi of Pi, of X of Pi. See, the story that's being told is that what I'm doing is setting the price, which is my marginal cost, equal to m times my marginal benefit. So it's a kind of a semi-golden rule thing. I'm taking account of the rest of the world, but I'm pretending that the rest of the world has marginal benefits just like mine, all right? And in general, the price is a scaled up version, scaled up by the externality internalizing multiplier. It's a scaled up version of my own marginal benefit, right? That's not optimal in the, not necessarily optimal in the Samuelson-Lindahl sense, because in the Samuelson-Lindahl sense, you should be scaling up by the sum of the Bi primes, not just your own. Okay, next. And I apologize for the, well, I'm holding the, okay. Now, okay, I'm going to make some really super simplifying assumptions and results. I put in the assumptions that I needed to get a clear-cut answer. I think some of this will carry over, but that remains to be seen. I want to make super simplifying assumptions that allow us to solve explicitly for the own price Pi and the socially optimal price P star. Okay. So this condition you could defend, that Bi prime is constant, you could defend by the fact that it's the global warming, climate change, is a stock externality. It's a function of the stock of carbon dioxide in the atmosphere. And in any small period, like 10 years, the flow is going to be more or less constant over that. The benefit, the marginal benefit of that flow is going to be more or less constant for any sub-period because the overall X isn't changing that all much in the sub-period. So this is a kind of a story where we're linearizing benefits, and that may be all right for a short period of time. Certainly if you go down to the day or the year or something like that, this is going to be an okay assumption. And now I assume this linear structure and marginal cost. So every marginal cost is equal to Ci, some shift variable, plus gamma times Xi. So the marginal costs are all parallel to each other, but some are higher and some are lower. Again, this thing, I can't really defend this very well. We could look at the alternatives. It's giving a base case that'll give a sharp result. Okay, so now from this we can derive the following. P star equals M times B bar. B bar is the average marginal benefit. I'm just rewriting this, the Samuelson Lindahl condition here, and you should, there's a reason I want to do it this way, so it's a peculiar looking way. Instead of the price being equal to the sum of the BIs, the price is equal to the average B times M. It's just transforming one form into another. Now here's something interesting though. Under these assumptions, you can show that PI equals MBI. What I'm doing is projecting my own benefit onto the rest of the world. The condition looks like the Samuelson condition, except that my BI is replacing B bar. So if my marginal benefit is lower than the average, I want a lower price than the average. If it's above the average, I want a higher price than the average. Okay, but now we have a kind of in this case, what gives this result is that lambda I equals M. Lambda I is the dx over dxi. Dx over dxi, that's going to equal M when we get in there and plug away with these simplifying assumptions. Okay, look, now there's assumptions in here for sure, but there's an interpretation of 11. It means that if there was, suppose there was voting, suppose there was a World Climate Assembly that voted on a uniform price. So you're voting on a price that's applied not only to you, but the whole rest of the world as well. Then by the median voter theorem, what you'll arrive at is a price corresponding to the median B, M times the median BI. This is M times the average BI, right? So at least in this case, this is as good as it gets, because if the median is close to the mean, we're coming close to this Samuelson-Lindahl condition. If it doesn't, then we don't come close. At least it's giving a result. If they were voting, then half of the people in the world would want a higher price than the PI, than M times the median of BI, and half the people in the world would want a lower price than MBI, right? So you get a social optimum price, the median equals the mean. Does this give a sense in which negotiating a uniform price tends to get a good outcome? Well, it's a result. It's very hard to find results in this area. And I want to note that I cannot get analogous satisfying results for voting on quantities. It's not even clear how you vote on quantities. okay? With a price, you can imagine how you vote on, at least in a science fiction sense, how you vote on the price. What is it you vote on for a quantity? And as I put in various proxies, and I'll get to that in a minute, on quantities, I just don't get this kind of an outcome. It's much more complicated because the parties are now paying attention to the initial caps that they are given, and they want to be able to, everyone wants to be able to sell caps at a high price and to buy caps at a low price, and you just get quite complicated, expressions. You don't get something like this. Now, I emphasize this is me. Maybe somebody else fooling around with this would get some some good outcome, but I, after fiddling around with it quite a bit, can't get a simple outcome for quantities. And now let me go on to this, and I'll go rapidly here. You know, I'm bending over backwards in the sense that I personally think that, along with Bill Nordhaus, along with many other economists, though not by far all, and maybe not even a majority, that a uniform price is a superior negotiating instrument. But maybe I'm being unfair to cap and trade. And let's try to set up a cap and trade system that looks like a quantity example of what voting on a uniform price would do. So now I'm switching notation also because it's just easier here, and I'm not going to go in that much detail anyway. So the world's total world emissions is Y. Now we're switching from abatement to emissions. Imagine country J has assigned emissions permits Yj by some reduced form linear, like that, okay? Now, what this is saying, this is kind of taking the Kyoto system and adding a Y to it to embody what is the world total emissions of Y. And if Y goes up, then my emissions my allowable permits go up by this amount. If these are assigned permits, if Y goes down, this goes down, presumably by this coefficient theta I. Okay, where theta I is greater than 0 and alpha, they're fixed distributional coefficients with these properties that they add up. The AJs add up to 0, the theta I's add up to 1, so that the sum of the Yj of Y equals Y. All right, so the interpretation is that, again, this looks a little bit like what Kyoto was trying to do. It was assigning coefficients, but it also, it wasn't allowing, it didn't embody a one-dimensional mechanism whereby a change in total emissions would be translated into individual assignments of caps. So it didn't do this exactly, but it's in the spirit of trying to make a quantity system look like that price system. Let's just examine it fairly and what it does and does not do. So, again, the interpretation is that this is a reduced form of assigned reductions from an assigned baseline level. Now, if Y is negotiated or voted on, we're going to get qualitatively something like what points 2 and 3, what we had before as a desirable property, because Y will be a focal point now, right, to negotiate on. And Y has qualitative properties of internalizing to some degree the externality, because it'd be the same kind of story here. You'd want a high Y to give yourself a high number of permits to trade in a cap and trade system. On the other hand, if Y is big, you don't like it because everyone else is then going to be emitting at a high emissions level. And now, okay, So suppose we went with this. I can't get any, out of this system, I cannot get properties like the one before, simple voting. But if Y is negotiated, we've got similar qualitative properties. There is a countervailing force to this Y. I think this issue of countervailing force is very important, actually. It's been neglected, but you want that instrument so that people are not just going to say me, me, me. They're coupled up with other people. Somehow this simple point has never really been made strongly before. Okay, but now let's ask, where do these stage 1 alpha J's and theta J's come from? Well, there's quantity negotiations again. This time there's 2n of these quantity negotiations to settle on theta J and alpha J. So here, as I said before, there's a critical distinction between international assignment of N caps and international negotiation of N caps. If in the sulfur dioxide program, the US government had just left it up to the power plants to decide on whatever they're doing, it would get everyone intuits it would go nowhere. It would be a ridiculous program. We don't have, we're negotiating, you do not have this overarching governmental structure. Okay, now here finally, look, I didn't put much form on this. Suppose that you had quantity assignments that are naturally symmetric in some sense. This is all intuitive, but that's all right. If you have a quantity assignment, let's say that everyone gets the same, an assignment of caps proportional to the number of people that are in the country and times Y. So the alpha J's are 0, theta J's are equal to, is equal to the population of this country divided by the population of the world. So what about naturally symmetric quantity? Would these make stage 1 distributional coefficients easier to accept? I don't think so, or I don't think this would make a critical difference. There will be arguments about the appropriate distribution formula here in this most general form, and even if the world if you think about simplifying formulas, no matter what it is, suppose that it's a formula that is assigning the same number of caps in the cap and trade system proportional to the population. Well, the language, the negotiating language is full of loose talk, like historical, each country should contribute according to its historical responsibility. What does that mean? Well, if it means anything, maybe it means that you can't, you shouldn't just assign according to the current flows, but according to the total amount of carbon dioxide that has been emitted by each nation. Something inversely proportional to that. So that would make the US and Europe be assigned lower quantities because their historic responsibility is higher. But historic responsibility, look, as even 40 years ago, maybe even 30 years ago, we didn't think this was such a big deal in general. The public didn't think that this was such a big deal. So why were they guilty of putting carbon dioxide into the atmosphere when no one really knew about the consequences, or that we would end up in a state where we are now? So here's some questions and comments. Oh, I think I'm almost going to make it. Look, here's a critical issue. Would serious side payments be required for acceptance of a uniform price? Suppose they are. You've got to make side payments in order to get them to accept this uniform price. Now, you could try to argue it, I think, at a very high level of abstraction. I personally think too high a level of abstraction, that this brings it back to n dimensions versus n dimensions, because you have to negotiate beforehand. There's n of these negotiations. And so the problems are not that fundamentally different. They both, when you include the part, the green fund that is necessary to get participation, it looks like a symmetric situation with is N versus N or N versus 2N or something like that. So I can't give an answer that says no at a high level of abstraction, but I think that there's less green fund transfer payments involved in setting a price than there are in setting in caps. So I recognize that this is an argument at a high level of abstraction that is true. If some game theorist parachuted down from the stratosphere, then they might say, well, these are the same ultimately because they're involving in transfers. Okay, it's a minimum price. Whoops. It's a minimum price on carbon, however attained. The country could go beyond. They could have a cap and trade system. They've got to align the price of that cap and trade system with the rest of the world. Now, so I'm thinking that a uniform price is a more natural focal point requiring less green fund transfers than any quantity subdivision assignment, such as that linear formula 12. Even with naturally symmetric quantity assignments, I don't get the kind of results I had, and I think that it's difficult to reach agreement. Now, I have a median voter story, but there's so many qualifications in that. You know, I had to really specify the model pretty tightly. So does this argument carry any weight because I had to put so much abstraction? I think it carries some weight. There is some story that's not totally ridiculous that in a sense justifies where the median voter will come out with respect to price. There's no such story with quantities. So it's not airtight. It's not airtight. So there's a combination of theory and judgments. My tentative conclusion: it is difficult to get nations to agree to anything on climate change, but negotiating one price is relatively easier than negotiating N quantities. I can't prove it at the highest level of abstraction, and they might be thought to be the same. Now, I want to quickly do this, and that'll wind it up. I want to extend, Bill Nordhaus came up recently, last year or two, introduced the basic idea of a climate club to overcome free riding. I want to extend his idea to accommodate a World Climate Assembly, a WCA, so I'm going to graft my idea onto his framework, but the framework is his, and that's carrying the bulk of the weight of the argument. So the idea is this: the members of the Climate Club, with this extension, agree to impose the same price of carbon on themselves. They try to reach agreement. Nordhaus left open, what is this price of carbon that the Climate Club agrees to? He just said it's $25, you're in or you're out. I'm extending that to saying that as the times change, they can change as the times change, they can change their voting, they can change their preferred club carbon price. So the members would try to reach agreement on the same price via one, but as a fallback, which you often need because there will be differences of opinion, they vote on the basis of one person, one vote on what is the uniform club carbon price. The members of the Climate Club agree to free trade among themselves, but each one also agrees to charge an ad valorem border tariff of, say, 5% on goods imported from any non-member country. Membership is voluntary, but members must agree to abide by the above conditions. So there's a penalty on not joining the Carbon Club and not agreeing to the uniform price that's voted on or somehow agreed upon in the Climate Club. The penalty is that your exports to the Climate Club countries will be charged, you'll have to pay 5%, as it were, to the importing country on goods imported from any non-member member. Now, Nordhaus shows he matches a couple of models, and it shows promising numerical outcomes. The Climate Assembly extension gives a voting rule for the flexible adjustment of the uniform price as changing conditions warrant. So it's a wrinkle on that I think ties up one loose end at least. Okay, I'm ending now. To me, this package seems like a constructive approach and a promising set of ideas. If we've really spelled out in some detail what goes on, and according to Nordhaus, something like 5% would be more than enough to get the majority or maybe all of the countries on board. This is very different from the path we took and are now sort of grasping towards assigning in targets. They're voluntary. In many cases, they represent what the country would do anyway. They are not confronting this problem of in different countries and putting in an overall framework such that they could get good results from such a thing. So I don't know. I regret that we went down this road of tradable permits. I think it would have been better had we started off with the concept of price and kept following that, because then there's a more natural transition to what I am talking about. And I just don't see how cap and trade is ever going to confront the problem of free riding on public goods.